Hello again. We do have construction going on, so expect an extra noise in the background. Okay, so this is, again, we're going back to the frame work. And let's see. No, I don't want that. I don't need that. Let's go that one. Okay. This is where we left off last time with the body of the robot, the frame. Now, I'm doing an example here. I mean, I really suggest that it's no fun if you just copy my design. We need to go, beyond that. I'm just trying to get you to the point where you understand how we could do things, and then we'll go on from there. Okay, so this is where we left off. This is robot version 3. And I'm going to do a file save as, and we're going to bump it to revision 4, just so that, I've got copies of everything. Okay, so now it's revision 4. Let's go ahead and change the comments up here. And that text is really small. Let's make it bigger. Okay, and today is actually the 21st. Okay, so let's see. What else do we do? We did have a glitch in there. Let me put the servo back on. As you remember, we have that. And my biggest problem is that the servos themselves, when you look at them top down, they don't line up. I mean, when I go to put it together, I can actually flip this one over. So they're symmetrical in that regard. So I can make these actual rotate in the right way. I do want it to look right in my design here, though, so I need to flip that over. And I mean, I could generate a one snap 2 and flip it, that thing in there. But we've actually got some options here. We can remember the if statement that we did in the programming. We can do the same thing here. Let me go down here, and this works fine on one side. So let me say if, and then, I need a variable. We can create one. I'm going to pass in something when we say snap joint. I'm going to pass in a number, and I'm going to say this is it's a servo rotation. I'm just say servo rot. Okay, so if servo rot is, remember, 2 equals for an equal test? Okay, if it equals 1, and get the brackets right, then we want to do that translation. Okay, now my brackets aren't matched, so we need a closing bracket. So now, if I say that, and I say redraw it, they go away. And that's expected, because of the fact that we're not even giving it a value, so it assumes 0. Now down here where we actually call snap joint, down here, if I put in a 1 and then tell it to redraw it, it just gives me the 1 on this one. For the other time we put in that snap joint, it doesn't do anything. I could put another number in here. I'm just going to put 0 in here just for consistency, even though that isn't really even necessary. Okay, so now I can put in a rotated 1. So let me say else, because we can do else up here too. And in here, I want something that looks really, really close to this. I want to copy that, paste that. Okay, so now when I hit F5, we're back to where we started. But not quite. I can make changes now. And I can change lots of things. I can, let me just make this one red, just to show that it is different. Okay, so that's the one I'm working with. Now I want to rotate this thing in the X direction, and it's not going to come out quite like we think. I mean, okay, if I look here, here's the X-axis, and so when I use a rotate command on the X-axis, it should rotate that around. The problem is everything's been translated and moved and rotated already. So what I think is the right way to rotate it may not be. So if I come in here and say, I just want to flip this thing over, and I know it's going to go to the wrong spot, okay, the X-axis we rotated 90 one way. If I say, let's go 90 the other direction and say redraw, that's not really what I wanted. So let me put that one back. And if I rotate just in the Z axis and just see it, well, you know, that, let me see here. Let me just, 180, not 100. That's not right either. That's not what I want. So let me put that back. So this one we haven't tried yet. Let me try this one. Well, that's halfway around. Let's go the other half. Okay. Now we've rotated it far enough. So now this the shaft on the servo is on the same orientation. It did it did mess us up. I mean, in terms of X, Y, Z, where we're located at. And I don't want to change it down here where we actually move the snap joint in, because remember, these don't really get printed. These are for our own visual as we're putting things together. So if I move it with the translate statement up here, that would be good. And again, things aren't always as we think they are, because, you know, here's the X, Y, and Z. You know, technically I want to move it in the Y direction a little bit. And if I come here in the translate, and that's 22.2, and if I just say 32.2, just move it 10 millimeters, that didn't move the direction I wanted. Let me put that back. Okay. This is -5. Let me just go to 0. That's right. That moved us a little bit. Okay, so let me go another 5. 10 millimeters. That got us, is that right? Are we lucky today? You know, that looks like it will just about work. Yeah. We've got little bits of gap on the sides. So now when I zoom out and look at this thing, now the servo points are in the same direction. Okay. Next problem. This shaft is really small. How do we connect to it? Okay, here's the servo motor. And this is out of your bag. Remember, there's two different types. Some of you got the ones, and they've got this hole on the bottom and a little adjustment thing in there. This actually, and it says continuous on the side. That is not the one that we want. I mean, yeah, they would work better, make the project easier, but that's, making it easy isn't always the goal. Okay, so here's the other one. It does not say continuous on it, and it doesn't have that hole in the bottom. Okay, so here's our servo motor that we're going to be using for the project, and it's got this shaft, and it's small. I don't know how we're going to connect to it, because I mean those it's got little notches on there that I can feel. I can barely see them. Oh, my eyes aren't that good anyway, but I can barely see them. Now we also got this baggie of parts with the servo motor, and on this baggie of parts, I can grab one of these parts out of here, and these are designed to snap into here. Now this thing only goes halfway around. Now, you know, if you're really careful, you can force it. And actually, this one goes all the way around, but at some point it would only go halfway around. So I can set it wherever I want it, and then it'll go halfway from there and back. So, you know, I guess what I want to do is we need to be able to connect to that with our printed stuff, and that's going to be tough. But to connect to this is a bigger thing, and it's got a big arm on it. It'll make it a lot easier for us. Okay, so what I want to do is I want to model this piece, or at least something that we can connect to. So let me make one of these, and then we'll see if we can get it stuck onto our servos, just so we can figure this out. Okay, so I've got a micrometer that tells me how big things are. And again, I want to stay in millimeters. And it's got this round piece on the side. And this comes in at just a little under 7 millimeters. Okay. And then this shaft, I'm just going to take the biggest, because to do a tapered slot takes a little bit more effort. Not that bad, but I'm not going to do that. So that's about halfway between 5 and 6. So it's about 5.5. And it actually tapers down to, you know, about 4, a little over 4. but we're just going to go with the 5.5. Okay, so I got a 7 millimeters for the big piece circle and about 5.5 for the rest. Okay, so I'm going to go back to this, and I want to do that. Okay, now first off, I'm going to turn off the frame so it's not in my way. And what I want to make is, oh, we can put it anywhere. This is a module, and this is a servo arm. Okay, so in here we need the round part, and that was small. That was 7 millimeters in diameter. So the D equals 7. H. Oh, what was H? Okay, let me, a second here. Okay, so this thing is actually, you know, close to 4 millimeters tall. A little less than, you know, about 3.8, but we'll just say 4. Okay. H equals 4. I didn't call it, so it doesn't draw it. Okay, so I need to call it servo arm. There we go. There it is. Teeny. Oop. Okay, so, you know, we could make it a little bit flatter. That's that $FN thing. We'll give it 16. Well, make it a little bit smoother. Okay. So there that is. That's the piece. Now we need the other part of this, and that was that's a cube. And we said it was 5.5 into one direction, and how long was it? Okay, how long was it? We're going to go for, you know, I'm going to go from the center of the, you know, thing and actually try to do it that way. And I get about, looks like about 17 millimeters. I want to be from the center of the hole to the end. And that's a little bit long, I know, but we're just going to go for that. Okay, so then back to small that. Okay, so we want to go about 17. How tall? I want to make it the same height as the other one, just for convenience sake. Close bracket, close that, that. Well, I would also like us to be centered. So, you know, this is the x direction, so I want to go minus x half of whatever that 5.5 is. Okay, so I need to translate. In the x direction, I want to go 5.5 divided by 2. Like that, okay? I said minus, didn't I? Okay. Okay. So there is the arm that goes on the end of the servo. Now, we need to put it in there. So let me, you know, if I actually put it on the servo itself, just so we can see it, I'm going to move it to before the servo. Let me just copy that whole thing. I'm going to say copy and delete it. And then servo arm. Okay. So now I want to put the servo arm. So on the servo. So if I actually go into the servo and actually say servo arm, and let me get rid of this up here. And I want to draw just the servo now. And I deleted the other thing that would have printed just the arm, so I need to say servo. Obviously, that's not where we want it. Let me translate that up. I mean, we know that the center of the circle in here, it's embedded inside the servo at the moment. We know that's centered on the coordinates right here. So it's in line with this thing. So we only need to go up. But I can just move it up. Okay, so let me just say translate. And I'm going to move it up. So it's 0, 0, 0x, 0y, z, 20. I have no idea how tall I need to be. That may be close. Not enough. 25. There's 30. That's a little bit too much. Okay, let me drop that back down. 28. You know, that's not bad. Okay, so we now have got an arm on there that we can work with. Okay. So now if I go back, and let's turn this back off, and go back and turn the whole frame on again, and zoom out, you can see that we have the arms on this thing. Yes, one's pointing up, one's pointing down. We need to somehow fix that. You know, we could. You know, we could actually we could pass an angle in to this. And if I come in here to this snap joint, I mean, okay, it's layered, okay? Because the snap joint calls the servo. And we've already got one value in here. I could put a second one. I could say arm rot. Arm rotation. And I'm just going to call it arm rot. Okay. And it's a second argument. So down here I can put in, one I'm going to put 0, and the other I'm going to put 90. Okay. So this comes in. We call the snap joint with a 1 and a 0, so it's going to put a 1 in the servo rot and a 0 in arm rotation. And then when we call servo from there, we really want to pass this arm rotation in. So we're just going to say arm rot. I know it goes to the next line. And this one down here, the same thing. Okay. Well, we haven't got it up in servo yet, so we have to go back up to servo. And this also is now going to be our arm rot, arm rotation. And before we translate this thing, let's rotate it. And it's going to be rotate. It was already nicely centered on our axis, so we can just say we're going to rotate it right around the z-axis with that. Because at this point, remember, that servo was pointing straight up. So let's see what this does. Okay, one didn't change, the other one rotated 90 degrees. Ah, that's awesome. Okay, so now let me both going 90. That looks good. About 120. You know, they're going both opposite directions, but you know, they're flipped. That's what they're supposed to do. So you have to kind of think about which way you want things to rotate. So now in my design, I can actually, oh, I've got that 1200. Ends up being the same. Okay. So now I can specify what I want for rotation. You know, if we do minus, no, that doesn't go us either. I was wondering if we could just go negative on the one. I mean, I'm sure we could figure out a formula to make it actually rotate the same way if we wanted to. But you know, okay, so we've now got arms on this thing, and we need to build plastic that we can plug into that. So what we can do is we can actually make a leg with that subtracted off. Let me build that, and then we're gonna quit this video. Okay, erase everything, and I want a leg. So module, you know, it could be a wheel, could be a leg, whatever you want to make it. Okay, I'm going to call it a leg. And in here, I want to take, really simple. I'm going to take a cube, and it's going to be, it's a leg. It's going to be a long, skinny piece. Okay, so let's make it 40 millimeters long, and let's make it 5 and 5. Okay. Let's do that. Okay. Gotta call it, otherwise it's not gonna draw it. Okay, so there's my leg. It's not real exciting, I must admit. Okay. Now, let's see. I'm gonna say center equals true just to make it. So that centers it right on the axis. So that'll make it easier for me to deal with. Now, I want to subtract from that the shape of this little piece. Okay. So I need to subtract that away. So I want a difference function. I want that as my base thing, and I want to subtract off, and that was called servo arm. Okay. Well, I'm subtracting off so much. You know, this is not really helping me. You know, maybe if I just get rid of the difference at the moment. Take those out of the equation so I can see where it's actually at. Okay, so the servo arm is actually going the other direction. And plus it's big. It's bigger. It's going to subtract everything off. Okay, so let me go ahead and flip this a little bit. So we'll make this, we'll make it 50, and we'll make this one 5, so we can get at least rotated the right way. And then I want to slide this whole thing down a little bit, because it's going to need to be, you know, we really want that the end of this thing to be really pretty close to the thing, so close to that. And it looks like the Y direction. That's pretty close. Now I want to make this leg has got to be bigger. At least part of it does. So I can make the whole thing bigger. Let's make it, instead of 5 wide, let's make it it's 8. Well, we made that thing with 7. Well, we're gonna have to go bigger. Okay, so now it's embedded in there. Let me put the difference back in. Okay, so now I've got a notch in this thing. So if I stick that onto the end of the servo, now it's going to rotate this whole thing, which is now quite a bit longer. So we can make this our leg. Now, you know, we don't have to make the whole thing 10 millimeters wide. We can actually narrow it down quite a bit less. And I know when I change the length, it's going to bother a whole bunch of things here. So let me just do that, and then we'll call it a video here. Let me do 25, and then, you know, that center is true is not doing what I want it to do. So let me just get rid of that for the moment. And just slide it over. The 10th is okay. We need to slide it over in the X direction. 10 divided by 2, or minus 5? Yeah, okay. And I want this slid, instead of the 20, let me go back to 0 for a second. There's the 0. Now we're on the bottom side, remember. So I need to, let me translate that down a little bit. Let's go minus 3. Let's see what that gives us. Minus 2. Okay. Now let me slide this thing back in the Y direction. Actually, it's going to be minus Y. Minus, let's see, that was 7, and then let's go 5. Okay, so there's our big piece. And I can make the leg. I can put a cylinder on that. And I'm going to need to translate it and rotate it. 0, 0, 0, because I don't know what it is yet, and I'm going to rotate it. And again, I'm going to just put 0, 0, 0, and this is going to be a cylinder. And I want this cylinder to be, we're going to make this thing another 20 long. Let's make it 30 long. H equals 30. I want it to be 5 millimeters in diameter. D equals, that's arbitrary. I just picked it out of the air. Okay. Okay, so obviously I need to rotate it, and that rotate, this is the X going this way, so if I rotate it on the X 90 degrees, we should be okay. Let's go for X 90. How about minus 90? Okay, and now I want to stick it way on out farther, and so I'm just going to slide it over, let's go for 20 in the Y direction. Oops, I hit an F in there. Now that sticks down lower than this. Maybe I should have just left that as a cube, in just a smaller cube. Let's just do that. Then we don't even have to rotate. That's going to be a mess if I don't do it, if I do it that way. Let's do a cube. And we want the height to be the same, but we want it smaller. Let's do 5, 5, well, 5. That'll be the same. Oh, we need the Y direction to be long. That should be 30. And of course I botched it. Oh, no semicolon. Okay, that's up. And we need to come down a little bit. The other one was translated down -2, so I suppose we probably have to do this -2. Okay. And we probably want that centered. This was 10, this is 5, so we have to go over 2.5. And that's going to be in the minus. There we go. There's our leg. Okay, that's enough for the moment. To get it to stick in there, we may glue it. We may the double-sided sticky tape. Hard to tell, but there we go. We've got a leg now. We can actually stick that onto the servo and make it do something. How are we going to walk with 2 legs? I don't know yet. I haven't figured that out. We'll let you guys worry about that.